In this video, we're going to learn how to evaluate logarithmic expressions. So for these examples, what we're going to do is we're going to use our knowledge of converting between logarithms and exponential forms to actually solve and find the value of the logarithmic expression below. So for each of these, we're trying to figure out what number log base 2 of 64 actually equals. So if we plug that into our calculator, what would we actually get? So essentially, we're trying to figure out log base 2 of 64. What does that equal? So I'm going to set it equal to x. X is just a variable value representing the number that I do not know. So I notice here that it's a logarithm, and I don't really know much about logarithms, but what I do know about them is that I can convert them into their exponent form. So I'm going to take my base here, which is 2. Then I'm going to take what's on the other side of the equal sign and put that into my exponent. So I have x is equal to what's inside here, which is 64. So in order to figure out what this logarithm equals, I need to find this value for x. But what's nice about writing it into its exponential form is I can now use, my calculator or just my basic knowledge of exponents to really figure out what that value of x actually is. So for this one, it's actually pretty simple if you know your bases of 2. If you don't, you can use your calculator to try to figure it out. But if you think about it, we've learned that 2 to the power of 6 is 64. 2 to the power of 6, we know, is equal to 64. So with that being said, what we can say is that log base 2 of 64, as a result, is equal to 6. So let's take a look at example 2 now. So here, again, remember we're trying to figure out what this logarithm equals. So we have log base 1/5 of 625 is equal to some number called x. Again, remember it's just the value for x representing what we don't know. So let's start by writing this into exponential form. Now because I have a fraction with an exponent here, I'm going to put it in parentheses. So we have 1/5 as our base because it was the base of our log to the power of x. And we need to figure out what power of x results in 625. This one's going to be a little bit trickier. So if I start off, what I notice is if I take 1/5 to larger power, so I start off with a power of 1, okay, that's 0.2, power of 2, that's 0.04, so I need that to get bigger. And as a result, I'm going to try something different. Instead of assuming that x is positive here, I'm going to experiment and see what happens when x is negative. And I notice when I make that exponent, so I take 1/5 to the power of -1 on my calculator, I end up with 5. So that's kind of heading in the right direction. So if I continue to experiment here, I find out 1/5 to the power of -2 is 25, -3 is 125, and if I continue to experiment in my calculator, I eventually find that 1/5 to the power of -4 eventually results in 625. Now the reason this is happening is because if you think about it, we know that 5 to the power of 4 gives us 625. We know that. And because this has a power of, or a base of 1/5, that's really 5 to the power of -1 if you convert it into, if you bring it up to the numerator. So that's where that -4 is coming from. Regardless, at the end of the day, we have now discovered what this x value is equal to. We can now state that log base 1/5 of 625 is equal to -4 because that power of -4 applied to 1/5 results in 625. Now let's take a look at this next one here. So here we have log base 5 of 0.2, and we need to figure out what that equals. So I'm going to set it equal to x. Now I'm going to write it into its exponential form. So base 5 to the power of x is equal to 0.2. Now I know that 5 to positive powers, so the power of 1 equals 5 to the power of 2 equals 25. So I know that those positive powers aren't going to help me, so I'm going to start with a negative power. So 5 to the power of negative 1. Well, if I do that, I find out right off the bat that 5 to the power of negative 1 is equal to 0.2. And as a result, I've actually solved my logarithm because I figured out which exponent here, applied to the 5, results in 0.2. So I can state log base 5 of 0.2 is equal to negative 1. And then finally, this final example here, again, we want to figure out what that logarithm is equal to. So we're going to take 81 to the power of x is equal to 3. So I started experimenting. I know it's not positive because 81 to the power of 1 is 81, and 81 to the power of 2 is 6,561. So it's not, at least not a large positive. So it's not 1 or 2 or 3 or etc. So then if I start trying negative numbers, do negative 1, well, that's immediately a really, really teeny number. So it's not going to be something like negative 1 or negative 2 or negative 3. So I have to try a different route here. What I do know, though, is that I know that 3 to the power of x equals 81 would be 3 to the power of 4 equals 81. So I'm going to start experimenting a little bit because I know that 4 might be important here. So if I start experimenting, instead of doing, negative 4 or 4, I'm going to try 1/4, making sure I put it in parentheses so that it accurately does it. So 81 to the power of 1/4, and I notice that 81 to the power of 1/4 results in 3. So that 4 relationship that I knew about with 3 and 81 came in handy here. And since 81 to the power of 1/4 is 3, we can say log of base 81 of 3 is equal to 1/4, because 81 to the power of 1/4 results in 3. So for this particular lesson, you have a lot of strategic guessing and checking here to kind of find your answer. And until we learn more about logarithms and exponents, that's where you're stuck. You have to use your knowledge of exponents. So some of them are going to be easy, like number 1. And then you have to kind of experiment a little bit to find what is that logarithm going to equal. How can I use exponents to help me? And then using your calculator to kind of strategically evaluate that logarithmic expression and find your answer.